can, again, take this to a comparator, because you have a spare one there. Put a variable resistor here, and connect this to one of the pins. Calculate this in a way, because you cannot give more voltage to the pin, more than 5 volts, you need to build the divider. So when it's on its maximum, it's, for example, 4.5 volts. But when it drops down to 10, I don't know, it's 3 volts or 2.5 volts, yeah? And then you set it here, the threshold, and then at this point you'll have either 1 or 0, and you can read with the program on the pin. If it's 1 or 0, then your battery is low. And then you can just stop the work. Just another option that you can. Or the second way is to take this pin, instead of building this comparator, use an analog to digital converter pin on the microchip and just read the voltage from here. And filter the battery threshold program. I mean, not with 1 and 0, but you can just read what value it gives. Yeah. There it is. So what you do is you get a board, you buy all the components. It should cost you like, I don't know, £20 max. You can get the small motors at Macklin's for, I don't know, £7. So your main cost is going to be the motors. For later on you can add an LCD and anything you like. This is a field that you can create anything that your mind pushes into. Now I'll be happy to answer any questions about this. I hope, yeah?
How do we program it?
How do you program it? I'll show you this in a couple of minutes. So, in the electronics part, do you have any questions? No.
Actually, sorry, one question. On the part where you have the circuit for the sensors, right, at the very end, after the comparator, you've got another
yeah, and LED and the resistor.
When you're saying that, obviously you put it onto the white line, obviously the white line is going to reflect the light a lot more, so therefore you're going to get a higher reading or whatever. But so what is that? I mean, so you're saying at that point, obviously because you could do in programming, you can just read
here's the thing.
the output.
If I read it programmably, the output of the sensor, which would be this point, I wouldn't use the comparator, I would just connect it to the analog to digital converter point. But because not all microcontrollers have a lot of inputs of analog to digital, I use this.
Fair enough.
Yeah? To save the analog digital converter for other things. But if we have enough, obviously, the comparators are not necessary. But again, the analog to digital conversion, it takes time. So if we want the program to run more like, if we want better performance in the program, we use just inputs as 1 and 0s, and just because checking an input takes less time than reading the analog voltage from the pin.
Yeah. Also, the majority, like some boards, got the actual resolution for the analog to digital converter is actually quite low.
Well,
some of you can get.
Yeah, in this case, it's not that low. It's for this microcontroller, it's 10 bits, which is which is like 1024. Which is quite fair for this project. But of course, you can use. There are chips. There are analog to digital converter chips separately that you can connect to the microcontroller, which have a higher resolution, or you can just use another microcontroller which has a higher precision analog to digital converter. Yeah.
Probably.
But in this case, I mean, I don't think it's that big of a problem. And also, well, I guess the good part is that you could auto set settings with analog digital converter, because in this case, you should put the robot on white surface and rotate the potentiometer while it gets the light on, so you understand that you have reached the threshold, and then leave it like that. But so it takes time to set all the sensors. But in the case of analog to digital, you could just have 2 buttons here, you could programmably set one button for black and the other one for white. So you would put the robot on the white surface, just press the white button, and it would just read the voltage and just save the voltage as white. And then put on black, just press the black one, and then it will just set the voltage as black.
And then those will be thresholds that.
Sorry?
And then those will be the thresholds that you'll be working
Yeah,
on.
and it will just work out programmably.
Yeah.
So you don't have to spin it. And it's a good idea because try to avoid always using mechanical components on circuit boards because they are not good they are not durable, they are not acting well in different conditions of weather, especially in your case, flying and super low and super high temperature. So yeah, of course. Yeah.
So I just want to ask, on your microcontroller block, where you've got like the outputs like the XTAL1,
Yeah.
what's the component between the two? You've got like
This?
yes. Is that
This is
another
a crystal resonator.
crystal resonator? Okay.
It's, in this case, just put a 16 megahertz one. You know, it is called quartz. In other words, crystal quartz. It is used to give pulses.
Is that built into the microcontroller then?
Actually, it has one built inside,
Yeah.
but the external one is put if you need like super precise frequencies. The inner one of this, I think it's you can use up to 8 megahertz or something.
Okay.
Yeah, but I personally always put external ones. For example, why you need sometimes external ones when you communicate your microcontroller with other microcontrollers or other devices, and the protocol which is used to communicate the two things, they need synchronization.
Central clock. Yeah.
Yeah, so you might need to run your program in a certain frequency or certain parts you need to run, so your microcontroller doesn't lose any data on the way or doesn't. So you get
Yeah.
yeah. That's the reason.
Yeah. Thank you.
But of course, these things are sensitive to mechanical hits and things like that. They can crack, and it happens when you drop the board or it touches. So yeah. Any other things about this? And also, I would recommend. Sorry, this is the simple version of getting low voltage. Yeah, getting the regulated 5 volts. I would use a step-down converter. Yeah. I will open another sensor of another circuit board of our robot, so you see how we made it and what components there are. Okay, any questions about this? Or should we get to the simulations? Simulations? Okay, turn on the projector, please.